Okay, so let's take a look at some examples here for cosecant and secant graphs. You kind of got an example in the last video, but here's some examples that start from scratch and don't really lay out exactly what you want to do. So I want to start by deciding whether I'm drawing a sine or cosine graph, because these cosecants and secants are going to be based on those sines and cosines. So cosecant is really a sine graph. So I'm going to draw a sine graph. Okay, so I've got the amplitude is 2, the period of sine is 2 pi divided by the number in front of the x, which is a 1. So that's perfect. I don't have any horizontal shift and vertical shift don't exist. Okay, so I don't need to worry about those. So that's perfect. So I've got an amplitude of 2, so this is going to go up 2 and down 2. It's got a period of 2 pi, so I'm all way out here at 2 pi. I'm drawing a sine graph, so cut this in half, and in half. Those are not really in half, so let's try again. Half and half and half. Close enough. And so this is going to start at 0. It's a sine graph. It's going to go up to the amplitude, come back to the midline, down to the amplitude, and back to the midline. Okay, so this is what my general graph looks like of the sine. That's not what I'm drawing. Okay, I'm not drawing the sine graph. I'm drawing the cosecant graph. So I actually want to draw cosecant. So let's draw that in blue. The cosecant has asymptotes everywhere that the sine graph crosses the x-axis. And the cosecant graph has its actual graph up at the amplitudes, the maximums and minimums for this sine graph. And so there is one period of the cosecant graph. It is completely based on the sine. And so if you feel better about erasing the sine and having just the cosecant in here, okay, because if I were to graph this on a graphing calculator, it's not going to have that sine stuff in there. Okay, so if you feel better about having that out of there, then please feel free. Okay, take that out. That's what the graph looks like of the cosecant graph. Okay, so now number 2, or example 2, I guess here. There's no numbers on them. We'll do decide that this is a cosine graph. And so I need the amplitude of a cosine graph, which is the absolute value of -3, which is important, the negative. Okay, the negative is important. And we've got the period is 2 pi divided by 2, which is just pi. And so I'm going to first draw in the cosine graph. So I've got an amplitude of 3, so this is going to go up 3, and it's going to go way down here to -3. It's going to end out here at pi. Remember that we're zooming in as far as we want to, so we're looking at just this one period here. The horizontal and vertical shifts, there are none of those, so that's the good news. And now I'm going to draw in the cosine. Now, because of the negative, the cosine's actually going to start down here at the bottom and end it down here at the bottom. Halfway in between, halfway in between, and halfway in between. It's going to come up to the midline, go up to the top of the amplitude, come down to the midline, and end finally down here. So it's going to look something like this. And I am going to undo that because I'm not drawing the cosine graph in. I'm drawing the secant graph in. So when I draw in the secant graph is everywhere that this crosses the x-axis, I have an asymptote. Everywhere that it has a maximum or a minimum, I've got my actual graph. And again, if you feel better about deleting out the cosine portion, okay, please feel free to do so. Okay, the cosine is just helping us sketch this graph. It's not actually part of the graph. Okay, so this is what the graph looks like if you were to put it in a calculator of -3 secant 2x. Now, let's look at the last example here. So the last example, I have a secant again. And so let's look at this again as a cosine. And so I've got an amplitude here of absolute value of -1, which is 1. I've got a period of 2 pi divided by 1, so that's good. And I've got a horizontal shift this time. Okay, a horizontal shift of x plus pi normally starts at 0, so I want to figure out where my new start is. Subtract pi from both sides, and I get x equals -pi. That's my new start. And I have an end over here at x plus pi. It usually ends at 2 pi. And so when I subtract pi from both sides, I get that this now is going to end over here at pi. So this starts over here at negative pi. It ends over here at positive pi. It's a cosine graph because the secant is the inverse of cosine. I've got halfway in between. Halfway in between is right here. Okay, halfway in between negative pi and pi is 0. So then halfway in between those is actually there. So I can stretch this out pretty far in my graph here. I've got an amplitude of 1, so this goes up 1 and down 1. Now I can go ahead and I can draw in the cosine graph. So the cosine, this has a negative in front, so it's going to start down here at the horizontal shift and at the bottom of the amplitude. It ends here at the end of the horizontal shift and at the amplitude. Goes up to the midline, goes up to the top of the amplitude, back down to the midline, and here's what my graph looks like for the cosine. So if I were drawing a cosine graph, I'd be done, but I'm not. And I'm not drawing a cosine, I'm drawing a secant. So I want to draw in the secant. Everywhere that this crosses the x-axis, or the midline for that matter, I'm going to draw in an asymptote, and everywhere that it has a maximum and minimum, I'm going to draw in my parabolas for my secant graph. Again, I think some of you like the fact when I erase this, so I'm going to erase it because this actually isn't part of the graph. This was to help us graph the graph. Okay, so it helped us to make that graph. It's not actually part of the graph. Okay, and so that's what the graph looks like of the secant graph based on the cosine, because it's the inverse. I've made a negative secant of x plus pi. Okay? Take your time. Make sure that you go through, answer the questions on the homework in your book. You're going to need to graph these. The best way to graph them is to do it. Okay? Just try it. Find the information. Check the information. Make sure that it's right. Try to graph. Check the graph. Make sure that it's right. And lots of ways you can do that with your partner, with me, with a graphing calculator. Okay, lots of apps that you could use if you wanted to, but make sure you're checking your answer, going through and attempting these, working hard at and trying to get an understanding of how this works.